Hey guys, welcome to my YouTube channel and you're watching Civil Engineering Ki Pathshala. My name is Janba Kumar and I'm here to present the first class of the theory of structure, that is the stability and indeterminacy of the structure. So in this class we are going to discuss about the different fundamental features of the theory of structure that we are going to use in the further classes. So in this class, let's discuss about the fundamental concept. The first fundamental concept, that is support system. So the support system is divided into two parts. The first part is the 2D support system and the second part is the 3D support system. So first of all we will discuss about the 2D support system and then we will discuss about the 3D support system. So in case of 2D support system, we have first one is the fixed support system. So in case of fixed support system, we have three number of unknowns reaction, that is Hx, Ry and moment about point Z is equal to 0. So in case of 2D fixed supports, there can be three reaction. First reaction is Ry, that is a vertical reaction. Second reaction can be Hx, that is a horizontal reaction, and the third reaction can be the moment about z-axis. So you can see in the figure 1.1a there is a number of reaction 3, and in the similar way you can see in figure 1.12 number of reaction is 3. So it is inclined but the number of reaction will be 3 only. So the second part is the hinge supports, and in case of hinge support you can see the hinge support is represented like the figure given in the symbols, and the hinge supports have two unknown reactions, two number of reactions. So hinge supports have basically one horizontal force, that is horizontal reaction, and one vertical supports reaction, that is Ry. You can see from the figure 1.21 there is a number of reaction 2, and you can also see in figure 1.2 part 2 number of reaction is 2. Yeah. The third part of the support system is the roller support system. The roller support system is represented by as shown in the figure, and it has only one number of reaction, that is acting vertically in upward directions. So you can see into the figure 1.3 part 2 the number of reaction is only 3, and it can be resolved into Rx and Ry when it is inclined to some angles. So at the roller supports there can be only one external independent reaction which is normal to the contact surface. The fourth part is the guided roller supports. So in case of guided roller supports we have two unknowns reaction. The first unknown reaction is Ry, that is acting vertically upward direction, and the second unknown reaction is the moment reaction, that is restraining into the rotation. So in case of guided roller, we have two unknown reaction. One is the vertical reaction, that is acting into the vertical direction, and the second one is the moment reaction. Now we will further go to the next part, that is the roller guided. Sorry. Now next part, that is a 1.1, that is the 2D internal joints. So at the internal joints we can see the internal hinge and internal roller. So at the internal hinge, the bending moment will be 0. So at the place where we are introducing the internal hinge, bending moment at that point will be 0. So at the internal hinge provided one additional equilibrium equation for the structure. So at the location where we will provide the internal hinge, it will introduce one additional equilibrium equation. The second part is internal roller. So at the internal roller, either axial force or the shear force will be 0. So you can see from the figure 1.6, roller system is called as an internal roller system, where the axial force is 0 or shear force is 0. So this is the internal joint sections where we have studied two parts. One is the internal hinge and second one is the internal roller. Now we will come to the third part, that is the 3D structures, or we can now discuss about the interlink. So if any member is connected by hinge at its end and is subjected to no external loading in between them, then it can be termed as an internal link and carries axial force only. So you can see that two hinges interconnected to each other, like B and C is connected to the internal hinge, and the link between these points is called as a internal link. Here the member BC is called as a link, and link BC carries only axial force, so there will be no bending moment at that place. So once we introduce the internal link, we are just basically carrying the only axial forces, not the bending moment forces. So internal release is also provided additional equation for the analysis of the structure. So whenever we are providing the internal link, it will also provide the additional equation for the structures, like we have provided into the internal hinge. So this is the basic concept about the internal links. Now, like similar to the 2D structure, we have 3D support system. In case of 3D support system, we have the similar kind of support system like the fixed support system, hinge support system, and the roller support system. So first of all, we will discuss about the fixed support system. So in at the 3D fixed support system, there can be 6 number of unknowns reaction. 3 unknown reaction will be Rx, Ry, Rz, and 3 moment reaction that can be introduced like the mx, my, and mz. So the fixed supports are also called as a built-in supports or built-up sections. So this type of support system have 6 number of unknowns reaction. In case of 3D hinge supports, we have 3 unknowns reaction like Rx, Ry, and Rz. So we have 3 number of unknown reaction, and in case of roller support system in 3D, we have only one number of unknown reactions that can be acted as a perpendicular to the contact surface. So these are the condition. Now we will discuss about the different structures and elements of the structure. So let us discuss about the different kind of beams that are acting as a structural members. So the first kind of supports beam is called as a simply supported beam. The simply supported is basically that kind of beam which is just resting on the simple supports, like we can see in figure 1.13. Here one supports is roller support and the second support is the hinge supports, and the beam is resting on that. So this kind of support system is called as a simply supported beam. And the second support system beam is called as a cantilever beam. Second type of beam is called as a cantilever beam. In that beam, one part of the beam is fixed and second part of the structure is free to move. So this type of beam is called as a cantilever beam. Third part of the beam is called as a propped cantilever beam. So this is the basically extension of the cantilever beam. In this beam, we have a one part is one support reaction is fixed one, and other end is just made as a propped. Other end is made as a other end is made as a simply supported. So it extends the vertical movement. And the third beam is called as a fixed beam. So both ends of the structure is fixed, and then the continuous beam. When the beam having more than one span, that kind of beam is called as a continuous beam. So these are the part of the element of the structures, and the first one is the beam, and the second part is the column is a basically vertical members which is a cylinder in nature. These are generally used to carry the axial compressive load and bending moment as shown in the figure. So you can see that in figure 1.1, that point load is acting through the center of gravity, so there will be no bending moment takes place. So this kind of structural system will have only axial compressive force, and in case of 1.18 part 2, you can see it have two kind of forces. That one is the axial compressive forces and the second one is the moment, because it is placed the force is placed at some eccentricity. So due to the eccentricity, the moment will be generated, and this kind of column will have bending moment and axial force only. So now the third part is the tie members. Tie members are basically the tension members of the truss and frame which is subjected to the axial tensile forces. So this was the part of the element of the structures. Now we will discuss about the type of the structure. What are the type of the structure? What are the basic type of structure that we are using for the structure, buildings or different kind of structural systems? So the first type of structure is truss. In case of truss, all the members are connected to the hinge. All the members are connected by the hinge. So here you can see the truss of the all the members are connected by hinge. So at this supports it is connected by hinge. So this supports all the members are connected by hinge. What are the advantage of connecting the member by hinge? So by providing the hinge, so in this cases the load will be transferred to the axial tension or axial compression. So there will be no bending moment takes place. Now the second part of the structure is the frame. In case of frame construction, either it is a pin jointed or the fixed jointed beam and column. Generally load are applied on the beam, and this type of loading causes the axial force, shear force and the bending moment to the frame. So this basically combination of beam and column is called as a frame. Next part is the cable connection. So cable connection are used to support the large span bridge. Cable are flexible members, and due to external loading it is subjected to the axial tensions only. So you can see the different kind of bridges that we are used in the ancient time or in the present time also, that like the Lakshman Jhula and Ram Jhula which is made at the Rishikesh, and this kind of structural system is made from the cable bridge. This kind of structural system is called as a cable bridge. Now the third part is the arch connections. So arch are used in bridge, dome roof, auditorium, where span of the structure are relatively more due to external loading. Arch can be subjected to the axial compression, shear force, and bending moment. So, arch are provided where the large span structure are required, and in that cases, the bending moment will be reduced due to the horizontal forces. So, these are the type of structural system that